Hello, Alvin ISD mathematicians. Today we're going to be applying our knowledge of percents. So how are we going to be doing that today? We're going to be solving problems with percents using concrete and pictorial models. You'll know you've gotten today's lesson when you can answer this question: what is 35% of 250, using a strip diagram, a percent bar, a proportion, or a ratio. All right, let's get our brains kind of warmed up and going. So as you look at this image, I want you to think about what you notice and what you wonder. I want you to pause the video and write down as many things as you can think of. Whenever you're done, please resume. All right, I'm so glad you're back. When I look at this, I notice that the 60% is only arrowing to 6 tiles, but there's 10 total tiles. I also notice that there's a 40 on the very far end of the strip diagram. And I'm wondering if this is kind of like how we used strip diagrams when we solved ratios and rates. But I'm also wondering why there's a percent. So maybe they're related somehow. I don't know. Let's figure it out. Throughout this unit, we've been using fractions and decimals to help us with our multiplicative thinking with ratios and rates. We're now going to be taking that and extending it further. So our knowledge of fraction, decimal, and percent conversions is really going to help us here. Notice that 100% is equivalent to the 1 whole. Our 50% is equivalent to half of the 100%. 25% is equivalent to a fourth of the whole. Be thinking about these things in these images as we move further into the lesson. All right, we're going to model today with some percents using some hands-on things. So grab 10 square tiles. If you don't have square tiles, grab 10 sticky notes or cut a piece of paper into square pieces, anything you have around the house. If you don't have anything like that around the house, but you do have access to the internet, you can go ahead and use your bookshelf and go to the square tiles part of your bookshelf. You're going to need 10 of whatever you choose to use, and you're going to want to lay them out in a row horizontally, just like the picture shows. So go ahead and pause the video and grab all of the materials that you will need today. All right, so we should have our 10 tiles or any material that we're choosing to use today for our learning, and they should be spaced horizontally right next to each other. So if this whole strip of tiles represents 20, so this entire thing represents 20. I want to know what numerical value does each individual piece have. So go ahead and pause this video. And I want you to write the value of each tile on the top of it. Whenever you're done with that, go ahead and resume. All right, guys, welcome back. So if our whole strip diagram represented 20, that means that each individual tile had a value of 10. Had a value of 2. And our 10 groups of 2 gave us the whole of 20. So now what I want you to do is take whatever resource you're using and flip it over now to the blank side. Now on that blank side, this strip diagram now represents 100%. So then what percent of the whole does each piece or each square represent? So take a moment to pause the video, process and think through the question, and then I want you to label each square with its percent value. Whenever you're done, please unpause the video and rejoin us. All right, you guys, you're right. Each tile is worth 10% because our 10 groups of 10 represent the 100%. Very good. So then to kind of bring it all together, each individual tile represented 10%, and it had a numerical value of 2. So each tile represented 10%, but also 2. Let's kind of think about that. Let's build that up. So my 10 groups of 10% gave me my whole of 100%. And then my 10 groups of 2 represented my whole of 20. So this entire strip diagram represented 100%, 100% of my number, which was 20. So now, with this in mind, let's kind of think of how we can find what 40% of 20 is. So I want you to take a moment and pause the video, and whenever you're ready to rejoin and you have your solution, unpause. All right, you guys, welcome back. Notice our strip diagram. We knew that 20 represented 100% of our number, which we've connected up here to our knowledge of ratio tables. So then from there, on the previous slide, we actually went from our 100% to understanding that 10% of 20 was 2. And if I knew that 10% of 20 was 2, then I can find what 40% of 20 is. 40% of 20 is 8. Notice our thinking that's displayed on the strip diagram is the same thinking that's in the ratio table that we've been working with when we've done rates and ratios and then conversions with unit fractions, unit ratios. So now we want to know what 25% of 20 is. Well, so I know 100% of the whole is 20. And I want to know what 25% is. The first way that I see that I can multiplicatively solve for my missing unknown is I can divide 100 by 4 to get to 25, which means I would divide 20 by 4 to get to my missing value, which is 5. So then 5 is 25% of 20. Now I want us to also notice that I can move up and down the percent bar as well. To get from 100 to 20, I can divide by 5. So then from 25 to my unknown, I can also divide by 5, which still creates this true statement. So 5 represents 25% of the value of 20. Now we want to know what 36 is 75% of what number. So now I know that this 36 value represents 75% of a number that I don't know what the whole value is. But I know that percents are always based out of 100% as a whole. So I want to think about how I can get from 75% and 36 to 100% in my unknown. So I recognize that I can get from 75% to 25% by dividing by 3, which means 36 divided by 3 gives me 12. So 12 represents 25% of my unknown number. Well, then now from 25%, I can scale up to 100% by multiplying by 4. Which means I'll scale 12 up to the unknown value by multiplying by 4. So my missing value is 48%, or 48. So then 36 is 75% of 48. Now I want to take a moment to show how this connects to our knowledge of ratio tables. We're comparing two things. We're comparing numbers, and then we're comparing percents. Now, we started off knowing that 75% of our number was 36. and we wanted to find what 100% was. So we divided both our ratios by 3 to find that 25%, or 1/4 of our unknown number, was 12. And if I knew what 1/4 or 25% was, I could multiply that by 4 to find my unknown, which was 48. Again, guys, same thinking is displayed. It's just a different way to represent the strategy. So 15 is what percent of 75? So I'm going to label my percent diagram with what I know. I know 75 represents my whole, which is 100%. Now I'm going to say 15 is probably somewhere over here. And I'm solving for this missing percent. So how can I get from 75 to 15? So I see that I can divide 75 by 5 to get to 15, which means I will divide 100% by 5 to get a value of 20%. Well, then that means that 15 is 20% of 75. All right, now we have 45% of 150. So 150 represents my whole, which is 100%. And I want to know what 45% is. So I want to think about how I can get multiplicatively to 45. So I have to think about factors of 45, which I know 5 is a factor of 45. So if I can get to 5%, then I can get back up to 45%. So to get to 5%, I will divide 100 by 20, which means I'll also divide 150 by 20. And when you divide 150 by 20, you get 70.5, 7.5, not 70.5. You get a value of 7.5. And now that I know what 5% is, I'm going to multiply 5 by 9 to get to what I'm trying to find. So then I will multiply 7.5 times 9 to find my missing value. So let's come up here and show our work. So we get that 67.5 is 45% of 100. $150, excuse me. All right, let's apply it. Matt spent $40 on groceries this weekend, which is 25% of his monthly budget for the grocery store. How much does he allocate or put aside for the grocery store each month? So I'm going to draw my strip diagram. And I know that this $40 only represents 25% of his budget. I want to know how much he allocates or gives away, puts aside for the grocery store every month. So that's going to actually represent his whole budget for groceries. So I see that I can multiply 25 by 4 to get to 100%. So then I will multiply 40 by 4 to find my entire grocery budget. So 4 groups of $40 is $160. So his grocery store budget is $160. All right, guys, we're now at our learning target. So if you take a moment, pause the video, And then whenever you're done and you want to check your answer, please come back and... All right, welcome back, boys and girls. Notice I set up my percent diagram, and 250 represented 100%, or the whole. So then I divided by 20 on both sides to find 5%, which was 12.5. And if I know 5%, then I knew I could multiply by 7 to find 35%. So 12.5 times 7 gave me a value of 87.5. So 87.5 is 35% of 250. Thank you for learning with us today.